Hey, what's going on, guys? In this video we are going to talk about convolution integral. Here we have the signal given. Let's say the question is asking us to find out compute y of t that is equal to x of t convolved with x of t. Okay, and if we express this one in terms of integral, that's going to look like this: y of t is equal to integral negative infinity to infinity, then x of t minus tau d tau. Okay, now we know that this is x of t, so if we draw x of tau, it's going to be the same graph because we just replace t with tau. And then if we sketch the graph, it's going to be exactly the same. The only thing is, instead of t we replace everything with tau, so we will have something like this. Okay, so this is x of tau and this is tau, and then this is 1 minus tau and this is 1 plus tau. Here minus 1, this is 1, and that's it for x of tau. Now what is x of negative tau is going to look like, because we need to know what is x of tau and also we have to know what is x of t minus tau, because these two are the things that's needed. These two are the things that's we want these two to calculate what is our final expression is. Okay, now let's go ahead and draw x negative tau. It's going to be exactly the same since it's symmetrical, so it's going to be the same thing. So x of minus tau is going to exactly the same thing. So for this one also we are going to have this one minus 1, this one plus 1, this is going to be 1 plus tau, and this is going to be 1 minus tau, and this graph is x of minus tau. X of tau and x of minus tau are same. Okay, now what's going to be the x of t minus tau? T minus tau is nothing but this tau is shifted to t. Since we don't know where the t is located, we just leave the y-axis blank and we just draw the x-axis, and then we just draw like this, and the middle part is going to be t because it's shifted to t. So this one is going to be t, and when we shift, this is going to become t minus 1 and this is going to become t plus 1, and here we have 1 plus tau, but since we have this one like this slope right here, we are going to have 1 plus tau minus t this side, and this side is going to be plus t, so this is going to be 1 minus tau plus t. Okay, we just shifted x of minus tau to t, so here in this side we will have plus t, this side we will have minus t, and the middle part is t. Okay, so this is our x of t minus tau. We need to know x of tau graph, that is this one, and we need to know what is x of t minus tau graph, that is this one. Okay, now based on these two things we are going to create cases, like based on the regions we are going to have there are many cases. Let's see the cases we are going to have. The first case we can have is when t plus 1 is this t plus 1 is less than negative 1. Okay, let's see how it's going to look like. Okay, let's draw that one. So initially we know that x of tau is like this, or you can say t is less than negative 2, because we need to know what is, like we are just shifting the t, we are looking at the possible location of t because we don't know where exactly t is located at. So that's why we say the first case that t plus 1 is less than negative 1. So in that case what we are going to have is we are going to have a graph like this, right? And we know that this graph end at t minus 1. Actually I am looking at x of tau because this is x of t minus tau and this is x of tau. Okay, let's mention the location. x of tau is what, -1 here, and then here we have 1, and then this is x of tau. If t plus 1, this is the t plus 1, you can see this part is the t plus 1, so that one is less than -1. That's why we have moved this one to this side. Okay, so this is our t plus 1 and this is t minus 1. Okay, from this one you can see this is x of t minus tau when t plus 1 is less than -1. From this one you can see there's no overlap for non-zero, like there's no overlap, so this is going to be 0. The whole thing, x of tau times x of t minus tau is going to be equal to 0. So if you do integral, that's integral of 0, that's going to be 0. So we can directly write y of t is equal to 0. So let's note this one. This is case 1, first case, when t plus 1 is less than -1. So we can note that one down here. I'm going to note it down here. T plus 1 less than -1, that gives us 0. Now let's look at the case 2. Case 2 is going to be when t plus 1 is, let's say the t plus 1 is greater than or equal to -1. So instead of less than -1, greater than or equal to -1. If it's greater than or equal to -1, then this is going to be somewhere here. This graph will be shifted because before we had t plus 1 less than -1, that's why we have moved this one. Now if it's greater than or equal to -1, let's say that is below 0. So let's say this is t plus 1 and this is t minus 1. Let's see what happens. Now when we do that, this is going to be different, right? Let's see what we get. So if it's less than 0, we are going to have overlap here in this region. -1 and t plus 1, there's overlap, right? So these two are going to remain. So from this one we can see the region -1 to t plus 1, there's an overlap. So this is the only region that's going to remain, because if one of them is non-zero, then that's the whole thing is going to be 0. You can see after -1 we don't have any axis for x of tau. T minus tau is here, but after t plus 1 there's no x of t minus tau. So since both of this region will be cancelled because one of them is non-zero, one of them is 0, and this after this also will be cancelled because other one is only one of them is non-zero and the other one is 0. So these two will be eliminated, and finally we will get an expression like this, and it's starting from -1 to t plus 1. So we will have the integrand, instead of -∞ to infinity, we put -1 to t plus 1, and then the expression is going to be 1 plus tau and then 1 minus tau plus t d tau, because you can see this region 1 minus tau plus t, that is this one, right? 1 minus tau plus t is this axis, and then 1 plus tau in the x of tau, this one is 1 plus tau. We are looking at this one. In the x of tau, you can see this region is 1 plus tau, and this one is 1 minus tau plus t. So that's why we have plugged that one right here. Okay, now all we have to do is just do the integration. When you do the integration for this one, you will end up with 1 over 6 t plus 2 cube. So this is going to be the expression when we have t plus 1 that is greater than or equal to -1. Let's note this one down here. So when t plus 1 is greater than or equal to -1, we have the expression that is 1 over 6 t plus 2 cube. Okay, so this is the second case. Actually this is case 2, right? Now let's look at the case 3. So now I'm going to change this one into case 3. So before we had when t plus 1 is greater than or equal to negative 1. Now let's look at the possible region right now. We can have t plus 1 greater than 0, because we had this one t plus 1, it's greater than negative 1 but it's less than 0. This is 0, but we had this one less than 0. Let's see what happens if it's greater than 0. Okay, so let's write that one down. If it's greater than 0, and also if it's happened, we can also rearrange this one and write it as t is negative 1 less greater than or equal to negative 1. And also we can add one more thing, like t plus 1 is less than 1. T plus 1 is less than 1. So we are looking at between 0 and 1. Okay, so let's go ahead and draw that one. So if it's between 0 and 1, we are going to have something like this. Okay, let's go ahead and draw this one. So if it's between 0 and 1, we are going to have something like this. And let's say, let's relabel everything. Okay, so this is 1, this is t plus 1, and this one is 0, and here we have, let's say this is t. Okay, let's say this is t, and let's say this is minus 1, and let's say this is t minus 1. Okay, and we know that okay, we are looking at these two conditions. T, when t is greater than or equal to negative 1, because we are looking at the condition t plus 1 is greater than or equal to 0. That's why we have this t plus 1. This is t plus 1. Okay, wait a minute. This is t plus 1 greater than or equal to 0. Yeah, this t plus 1 is greater than or equal to 0. So we have this one here, right, between 0 and 1. And the next one is t plus 1 is less than 1. That's why we have this in between, right, in between 0 and 1. So these are the two conditions we have. And this one, t plus 1 less than 1, if I bring this one to the other side, we can also write this one as t less than 0. If I bring this one to this side, negative 1 plus 1 cancels, so we get t less than 0. So we can express this integral going from 0 to, so there are 3 possible integral we can have. Okay, let's go ahead and do that. Let's look at the overlapping things. So here you can see in these two we have non-zero region. From here to here we have non-zero for both. Non-zero for both. Here to here also we have non-zero for both. Here to here also we have non-zero for both. So these are 3 regions we have. So we are going to have 3 different integrals. Now let's get, this is previous one. Let's get rid of this one. Let's see what are the regions we are going to have. So when we do the integration, let's express everything. Y of t, that's going to be integral. First one is negative 1 to t. So negative 1 to t. At the time we have this one. This line is, if you look at x plus x of tau, this is x of tau. That is 1 plus tau. So this one is 1 plus tau. 1 plus tau. And at the same time we have this one, 1 plus tau minus t. So 1 plus tau minus t until here. So that one is going to be here, 1 plus tau minus t. d tau plus integral, next one is t to 0, at that region we have this 1 plus tau, and also we have 1 minus tau, this line 1 minus tau plus t, this is the one, right, this slope. So 1 minus tau plus t d tau, and the third one we have is from 0 to t plus 1, at that region we have this downslope for x of tau, that's 1 minus tau, and the downslope of this x of tau minus t, that's 1 minus tau plus t, 1 minus tau plus t. Okay, so we just have to integrate everything. If we do that, we are going to end up with something like this: 1 over 6 negative t cube plus 3t plus 2 plus minus 1 over 6 t square plus 6t plus 6, then plus 1 over 6 negative t cube plus 3t plus 2. So this is what we are going to have after we do the integration. And if we simplify furthermore, we are going to have the final expression that's going to look like this: 1 over 3 minus t cube plus 3t plus 2 plus minus 1 over 6 t square plus 6t plus 6. So this is what we are going to have when the region is between 0 and 1, right? Between 0 and 1. So let's write this one as 0 t1. So in that way we will have this expression. Let's write this expression also. The expression is 1 over 3 negative t cube plus 3t plus 2 plus 2, and then plus negative 1 over 6 t square plus 6t plus 6. Now this is our third case. Now the fourth case we can have is when t minus 1 is equal greater than or equal to negative 1. Before we had, you can see here we have t minus 1 that is less than negative 1, but if it's greater than negative 1, it's going to go inside, right? So we are going to have a graph that's going to look like this. Let's move this one inside, or we can just get rid of this one. Instead of putting like this, I'm going to move this. This is going to be our t, right? This is t minus 1, and this is going to be x of tau right now, and this one is going to be x of t minus tau. X of t minus tau. If we switch that like that, the region is going to be what? We are going to have different regions. Let's get rid of this previous one. So this is going to be case 4. Okay, in this one, if this is t minus 1, this is going to be t plus 1, and this one is going to be negative 1, and this is going to be positive 1, and this one is going to be 0 right now. This is 0, and this one is going to be t, and that's it. So in this way we will have the region that is going to be t minus 1 is greater than or equal to negative 1. In that way, if we rearrange this one, that's going to be t is greater than or equal to 0, and also we can have t minus 1 is less than or equal to 0. You can see t minus 1 less than or equal to 0. That's why we have t minus 1 here. And if we rearrange this one, that's going to give us t is less than 1. Okay. Now let's see the non-zero overlapping parts. Okay. Now this is going to be, here you can see, for this one from here to here we have non-zero. Here to here we have non-zero. Here to here we have non-zero. It's exactly the same thing like before, but the limits of integration is going to be changed. Now for this one, you can see first one is going from what? T minus 1 to 0. So that's going to be our first integral. So this integral is going to be t minus 1 to 0. At that region, what do we have? T minus 1 to 0. This is our x of tau graph. In the x of tau graph, we have the upper slope, that's 1 plus tau. That is correct. And also in the x of t minus tau, we have upper slope, that's 1 plus t minus tau minus t. That's also correct. So we have the correct expression for the first one, so we can just keep it as it is. Now let's look at the second region, 0 to t. So this one, instead of t to 0, we should put t 0 to t. 0 to t. Okay. And at that region, let's see what we have. Upper slope of x of t minus tau, that's 1 plus t minus tau. So this one should be 1 plus t minus tau. Okay, let's change this one into 1 plus t minus 1, actually 1 plus tau minus t. So this one is minus. And we are looking at 0 to t. We have upper slope of this one, but x of tau is down slope, that is what? 1 minus tau. So this one should be minus. And then the last region, t to 1. So this one should be t to 1. Okay, at that region, what do we have? T to 1, we have x of tau is down slope, 1 minus tau, that one is here. And then x of t minus tau down slope also, that is what? 1 minus tau plus t, 1 minus tau plus t. So the things are correct here. And I forgot to put a d tau here. This is also d tau. Now all we have to do is just do the integration. Let's go get rid of the previous one. Okay, let's see what we get after we integrate. After we do this, we are looking at case 4. After we do this integration, this is going to become like 1 over 6 t cube minus 3t plus 2 plus 1 over 6t t square minus 6t plus 6 plus 1 over 6 t cube minus 3t plus 2. And if we simplify this one, that's going to give us, let's continue here. If we simplify this one, that's going to give us 1 over 3 t cube minus 3t plus 2, and then plus 1 over 6t t square minus 6t plus 6. Okay, so this is going to be the final expression. Now let's go ahead and write this one here. So here we can write this region, this path going from t is, okay, we can express this one as -1 to 0. T is between -1. Okay, that one was previous one. This one is here we have t that is between 1 and 0. The previous one was negative. Oh, this one should be t is less than 1. This is for the previous one, it was negative 1. Now this one should be less than 1, right? So this one should be t is between 1. Okay, in that region we are going to have this final expression 1 plus, let's write this one down, 1 over 3 t cube minus 3t plus 2 plus 1 over 6t t square minus 6t plus 6. Okay, so this is between 0 and 1. Now let's look at the case 5. Case 5, we are going to look at the situation where let's try to rearrange this one. X of tau, let's see what happens if t minus 1 is greater than 0. We didn't had the situation before. Okay, if t minus tau is greater than 0, the graph is going to look like this. So this is going to become t minus 1. This is going to become t minus 1, and this is going to be positive 1, and then this one is t, and this is t plus 1, t minus 1, t plus 1, this is 0. Okay, this is t minus tau, and this is case 5. We are looking at the new case 5, and in this region, if we put this region, our region is going to change. Let's see what it's going to be. Here you can see t minus 1 is greater than 0, so that's the first condition. T minus 1 is greater than 0, greater than or equal to 0. If we rearrange this one, t is greater than or equal to 1. And also you can see t minus 1 is less than 1. T minus 1 is less than 1. If you rearrange this one, this is going to be t is less than 2. Okay, so this is our new region. Now let's see non-zero overlapping like regions. T minus 1 to 1 is the only region that's non-zero overlap. So this is for this one, this is the only region that's non-zero overlap, right? So we are just going to have one integral. Okay, let's get rid of all this previous one. For this one, we are looking at case 5. Yeah, y of t is going to be equal to, starting from t minus 1 to 1, going from t minus 1 to 1, t minus 1 to 1. So from t minus 1 to 1, we have this x of t minus tau graph going up. That's 1 plus t tau minus t, 1 plus tau minus t, and also we have this x of tau graph coming down, that is 1 minus tau d tau. If we do the integration and solve this one, we are going to get negative 1 over 6 t minus 2 cube. Okay, so this is for this region. Now generally we can express this region as t is, okay, if here we can see t is less than 2, so t is between 1 and 2. So let's write this one somewhere here. Okay, let's say t is between 1 and 2. At that time we have this expression. Let's use a different color. Let's use white. Okay, minus 1 over 6 t minus 2 cube. Okay, this is the next region. And the last region, let's look at case 6. Now we have seen all the situation. Now the only thing is we have to just move it away from here. Like, let's see if x of t minus tau is here. If it like this, then from this one you can clearly see the region is going to change right now. Let's express the new region, and also these bottom parts we have to change. This one, this is okay. This is t minus 1, this is t plus 1, and this one is t. And the region is going to be what? With this t minus 1 is greater than or equal to 1. You can see this greater than or equal to 1. So in that one, if you rearrange this one, we can also say t is greater than or equal to 2. So if it happens, you can see there's no non-zero overlap. So the whole thing is going to be 0. So we can directly write y of t is equal to 0 because no overlap. No overlap. And that's going to be our last condition. So y of t is 0 in the last condition. So let's get rid of all of these things and express the last one. Last one, we found out that between like else, or we can say 0, otherwise else. Okay, so these are the things we are going to use in order to express our final piecewise function. Like, we can express a final answer as piecewise function. So we have found out, let's express everything. Let me write again. Okay, for this one, we know that between negative to, like, let's look at the regions. T plus 1 less than negative 1. At that region we have 0. And let's see this one. T plus 1 is greater than or equal to negative 1. And if you move this one, also at that time, I forgot to mention, that region we can, if you clearly see that region, that was minus 2, between t was between minus 2 and negative 1 at that region. So that one was 1 over 6 t plus 2 cube. And then the next region was minus 1. Okay, let's express it, write the expression first. So we had 1 over 3 minus t cube plus 3t plus 2 plus minus 1 over 6t t square plus 6t plus 6, when the region was minus 1 to 0. And also we had 1 over 3 t cube minus 3t plus 2 plus 1 over 6t t square minus 6t plus 6, when the region was between, when t is between 0 and 1. And also we had 1 over 6 t minus 2 cube. That was when the region was, when t was between 1 and 2, and 0 else. Okay, and that's it. That's our piecewise function, and that's our final solution. I hope this helps. Thanks for watching.